Hello and welcome. Today we are having some sets of questions which are very challenging for Year 11 student. This is IGCSE Mathematics. So the three questions, I've just received them. So one is from function. The second one is also from function, just a part as another part of the first one. The third one is from bearing. The third one is from bearing, this one, but it's not really bearing at the moment. The question you're solving is actually speed, distance, and time. So let's work with the question one by one. So in the first question, simplify giving your answer as a single fraction. So we have f of x being given as 7 minus 2x. We have g of x, which is 10 over x, and x is not equal to 0, just basically because any number divided by 0 gives an infinite value. And then h of x is 27 to the power of x. That is interesting. Now, let's check out the first example, which was simple, a 3-mark question, which they said we find 1 over f of x plus g of x. So this is a direct question. They just want you to solve algebraic fractions. So we are going to do 1 over f of x, which is 7 minus 2x, plus g of x, which is 10 over x. Remember, addition of fraction, the first thing we need to have is a common denominator. And because these are two different sets of fraction, the common denominator here would be x multiplied by 7 minus 2x. So this is a common denominator, and the various ways which you can solve the fraction with, you can technically choose to take this divided by this, which gives you x. You can just choose to do so, which will give you x, or we just do the normal way. The simpler way is just multiplying this fraction by the denominator, which is x into 7 minus 2x, and then we multiply the other one again into x multiplied by 7 minus 2x. By multiplication, the denominator will cancel, so we are remaining with x multiplied by 1 plus the other one, which is again x cancelling with the other one, which is 10 into 7 minus 2x. The common denominator remains to be the same, x into 7 minus 2x. Now, we can solve this one, by the way, but I prefer we start with the numerator. So numerator. So x times 1 is x, and then 10 times 7 is plus 70, then 10 times negative 2x is minus 20x. Simplify it. Simplifying it means that we just collect the like terms together in this case. So this one combines, so we are going to have 70. Now minus 20 plus x is minus 19x. This is our numerator. Then we go to denominator. For the denominator, we just have the value, which was x into 7 minus 2x. A single bracket expansion. So x times 7 we've said is 7x, and then x times negative 2x is negative 2x squared. Now this is the denominator. We now combine the numerator and the denominator. The numerator is 70 minus 19x, and the denominator is 7x minus 2x squared. Simple as that. That is how we solve that question. It's a simple function, algebraic functions, which we're just solving them as simple as that. The next part is for us to find the inverse of h, given that that inverse is also the x part is 19,683. So what was h? H in our case is 27 to the power of x. So h of x is 27 to the power of x. So we find its inverse. For this one, I'm going to do it with the longest method possible. Reason being, I want us to understand how to make subject of the formula with values which have powers and also a logarithm concept. So I'll be combining them in one set. So h of x means that we're going to have 27 to the power of x. So we have to do the inverse. The inverse means we just put it as y is equals to 27 to the power of x. So where there is x, we are going to change with y, and y we interchange with x, giving us x is equals to 27 to the power of y. Now we make y the subject of the formula. By doing so, we will have calculated the inverse of this question. Now, remember that because y is a power, the only way to make it a subject is by introducing logarithm. So the logarithm of x is equal to the logarithm of 27 to the power of y. The multiplicative law of logarithm, when we have powers, we have to take this power to the other side. So logarithm of x is equals to y log 27. So since we want only 27, or we are looking for only y, so we are going to divide both sides by log 27. Meaning we can cancel this one out, and therefore our y is going to be logarithm of x divided by the logarithm of 27. These logarithms are based 10, so they are logarithm to the base of 10. Now, we now find the question. They say we find the h inverse of 19,683. So, because we've already found the inverse of h, which is the inverse of h, which was logarithm of x divided by the logarithm of 27. So this means we are going to replace it as logarithm of x. Where there is x, we are going to put as 19,683 divided by the logarithm of 27. Logarithm, they are just different forms of numbers. We can put them in index form or in logarithm forms. So let's try and put 19,683 in index form. If you want to know that, the best way to can put 27 into index form is by splitting it into components of 3. Therefore, we can also try and see whether 19,683 is divisible by 3 just by adding the numbers. 1 plus 9 is 10, 10 plus 6 is 16, 16 plus 8 is 24, and 24 plus 3 is 27, meaning it's divisible by 3, and therefore it can also be divisible by 27, although not always the case. So in simple terms, I'm trying to say that we make sure that we have the powers of 27. It's easier that way. So we now just check them. 27 times 27 is 700, and you can just check it with your calculator. 729. We are not yet there. We multiply it again by 27, which is 19,683. This means that the logarithm of 19,683 can be written in the basis of 27 to the power of 3, and the denominator one can be written as logarithm of 27 to the power of 1. As I told you earlier on that if we have a logarithm and the number next to it has a power, we bring it to the beginning of the value. So this 1 and this 3 will be at the beginning. So we are going to have 3 log 27 all over 1 log 27. The reason why we used 1 here is because 27 raised to the power of 1 still remains to be 27. So the logarithm will cancel out, and we are going to have 3 over 1, which is 3. 3 over 1, which is 3. That is how that question is solved. Well, we go to the other question, which is the bearing question. So in this question, the diagram shows a triangular field ABC on a horizontal ground. So Olav runs from A to B at a constant speed of 4 meters per second. Then B to C at a constant speed of 3 meters per second. And then C to A at a constant speed again, but we are not told of what the speed is. His average speed for the whole journey is 3,600 meters per second. Actually, not 3,600 meters per second, 3.6 meters per second. So let's now calculate the speed that he is running from C to A. So from C to A, one thing we need to know is that we don't have that value. So we are only looking for the distance. So not the distance, but the time taken, because speed is equals to distance divided by time. So we have the distance, we are missing time. So the only way to find time is to take the total time taken, and then we divide, we subtract the time for the other two. So total time taken, remember, total time I'll just write here, total time is given by, total distance divided by the average speed. And the total distance, total distance here means we take the 150, we add it to 120, we add it to 180, those distances given there. So which is 450 meters, divided by the average speed, which is 3.6. Using your calculator, it will be easier for you to divide that. So 450 divided by 3.6, giving us 125 seconds. So this is the total time. So we are also going to look for the time from A to B. So from A to B, the time spent is distance over speed, which is 120 divided by the speed, which is 4 meters per second, giving us a distance, a time of 30 seconds. Again, from B to C, the time taken is the total distance, which is from B to C 180, divided by the time, which is 3, not the time, the speed, which gives us 180 divided by 3 gives us 60 seconds. So if you check the time taken for the two distances is 60 plus 30, which gives us 90 seconds. So the remaining time for that they are going to use from C to A is we take 125, we subtract 90 seconds, which gives us 35 seconds. So this is the time taken from C to A. So this is 35 seconds. So the speed from C to A will be distance over time. That distance is 150 meters, and that time is 35 seconds. So if you divide this 150 divided by 35 is 4.285 something. I'm just going to write it as 4.28, 4.3 meters per second. I've just rounded off, but you can use it as 4.285 depending on whatever accuracy the question is giving. That is how you could have solved that question and so many other. In case there is another question which will be difficult or something that you would like me to solve, just put it down and I will be able to solve it. Thank you.